Hey everyone, in this video I'm going to discuss and configure Eigrp named mode. In a previous one we looked at classic mode, and here we're going to look at named mode. And one of the biggest differences is not only does it, of course, support all of the existing Eigrp features, it also supports multiple address families. So instead of having a process for IPv4 Eigrp running and another process for the IPv6 Eigrp, we're going to be able to have one process for both IPv4 and IPv6 in our named mode configuration. By default, named mode uses wide metrics. Wide metrics is an expansion of the classic metric to allow for faster than 1 gigabit LAN interfaces or interfaces. So if you look at the classic calculation or metrics, a 1 gigabit interface looks the same as a 10 gigabit interface, and we know that that's not true. So wide metrics will allow for those additional greater speeds. And it is configured or has a hierarchy in its configuration. And there are 3 different modes that we look at, or 3 different levels maybe we look at. The first is the address family, and that's where we're going to configure our overall Eigrp operation. So for example, our networks, which interfaces do we want to participate in Eigrp, our router ID. And the next is the topology, which here are the configurations that impact the topology table. So it's kind of intuitive that way. For example, those things, couple of those things we'd be looking at would be load balancing and redistribution, which we will actually look at later. And then we have our interface sublevel, and these are the commands pertaining to Eigrp interfaces. For example, timers, whether or not the interface is passive, and summary addressing. When we look at trying to configure Eigrp named mode, we have just the basics here. The first thing we've got to do is enable our Eigrp process. And we do that with the router Eigrp and then give it a name instead of a number this time. They want to initialize the address family using the address family command. We have options of IPv4, IPv6, unicast, and then our VRF name. Then we have to specify the autonomous system number that we're going to use. By default, unicast is used by default, so we don't have to specify that. We can simply type in our case, we're going to just look at configuring it for IPv4 and IPv6. So we would just type in address family, IPv4, autonomous system, and then the autonomous system number, and then the same thing for IPv6. And then we want to activate our Eigrp on our specific interfaces. So we can use the network and then the network and mask command. In addition to the basics here, we will configure a router ID and a passive interface in this video. So here's the topology we're going to be working with, a basic 3 router topology with an access layer here. We're not going to do anything with these hosts. They're just there to signify that, hey, we're routing, and then we have users that get access from somewhere. And our access layer in this case is going to be where we configure our passive interface. And then over here, although I see I didn't label it, I have a loopback interface configured. I'll put that there. I only did this just for an additional network for us to route, just so we had something else to see in our routing tables. I've already configured the IPv4 and IPv6 addresses, so we have our 3 router and our switch. And for example, if you want to look back at this later, what I put here are the networks and the prefixes, and then the actual host address by the interfaces. So for our Ethernet 0 interface, in our case, I never put the speed, so I always put an E0. So if you have fast Ethernet and you want to do this as well, you do fast Ethernet, you use your fast Ethernet interface. I'm using a gigabit interface, I'll use mine. So for this, I'm just signifying that, hey, basically this is an Ethernet interface and it's interface 0. But anyway, so the address here would be 192.168.1.1, and the IPv6 address would be 2001 db81::1. And you just kind of keep following that through. So this one up here then would be 192.168.1.2 and 2001 db81::2. All right, so let's go ahead and start configuring our Eigrp. I haven't configured Eigrp on all 3 routers yet, on any of the routers yet. So we'll definitely have some redundancy here. You'll see it a few times. You might even want to listen to this at a faster speed. So I'm going to go ahead and bring over the terminal window for R1. All right, so I've brought the terminal window over for R1. Let's go ahead and start configuring our named Eigrp. Like I said, I've already put the addressing in, so all we have to do is configure the routing. router EIGRP, and then give it a name. You choose the name. You probably want something that's intuitive to the location or the actual, where it's geographically. So your autonomous system there. I'm just going to go with example. I'm just going to call this example, router EIGRP example. So my process name is example. And the first thing we'll do is our IPv4 address families. Address family IPv4. Remember, I don't have to specify unicast because it's the default, but I do have to specify an autonomous system number. Autonomous. I'm going to tab complete that. Except for I can't spell. That's why I tab complete. There we go. I'd already spelled it wrong early on. So address dash family IPv4 autonomous system. I'm just going to use autonomous system number 1 as my example. And now we've got to specify the networks that we want to participate in the routing. Or the interfaces that we want to participate in routing. So I'm going to do both the interfaces here. And I'm going to specify them this time. I'll specify the interfaces that are going to participate in EIGRP a couple different ways. This time I'm actually going to be very finite about it, and I'm going to do the networks and the actual mask. So for the E1 is 192.168.3.0 network, and the E0 interface is 192.168.1.0 network. If I could have done something a little different here. I could have made this network 192.168.3.0/30, and then maybe had another network over here that was 3.4/30, and then I could do 3.0 and then do the wildcard that's opposite of 30, and then that would mean this interface, that this other .4 interface wouldn't be participating in EIGRP. I didn't do that. I kept it simple. So our network and our network mask or wildcard mask, and we go ahead and hit enter. And then I'm just going to hit the up arrow here. We'll replace that 3 with a 1 to specify the other interface, the E0 interface that's going to participate in EIGRP. And at the basic level, we're done right now for IPv4. Now let's go ahead and enable it for IPv6. It's actually pretty easy for IPv6. All you have to do is enable the process, the IPv6 address family, and automatically by default all interfaces are included. So there are no network statements that you have to configure. And if you have an interface you don't want to participate in EIGRP IPv6 routing, you'll have to actually shut that process down within this routing process. Sorry. We want all of ours to participate, so that's fine, but all we need to do is address family IPv6 and our autonomous system number of 1. I just tab complete. Whoops, I forget this every time. You gotta enable IPv6 routing first. I just forgot to do it. So that's okay. Exit IPv6 unicast routing. Now it's enabled. Now let's go into our EIGRP process and enable IPv6 EIGRP routing. Router EIGRP in the name. Tab complete. IPv6. Autonomous system number is still 1. And now that it's actually completely enabled for all the interfaces, we don't have to do anything else at this point. Here's where we would specify the router ID if we needed to. In this case, we will. I mean, we'll go back when this is working, and I'll go ahead and configure the router ID. But router ID can be automatically or dynamically found, and that's the default operation. It'll first use the highest up loopback address. If it doesn't have one of those, it will use the highest up physical interface for IPv4, because the router ID is that same dotted decimal form as an IPv4 address. If there's no IPv4 running, then you will have to specify a router ID in IPv6. But if IPv4 is running, then it will use as its router ID the highest up loopback interface. If that doesn't exist, the highest up physical interface. And I'm going to specify router ID, but I'm not going to do that yet. Let's get all our routing going first. So we're going to move into router 2 or R2 and go ahead and configure that. Whoops. Sorry, I hit enter and it clicked away. So, let's go over to our R2 here. So what do we have to do? Router EIGRP. And we used example. And then address family, IPv4, autonomous system 1. Again, I think you guys know this at this point. You've done plenty. If you're watching this, you've probably done plenty within these routers. Whenever you see me start something and then all of a sudden it finishes, I'm just tab completing it because I'm going to misspell it as almost a given. So this is just faster. And that means, just remember, you start part of the command, hit tab, it'll finish it as long as it understands what you're trying to do. So address family IPv4 autonomous system 1. And then if I look over here, we've got 192, 168, 10, and 20. Oh, that's right. I was not going to do that. I was just going to do the network statement this time. I'm sorry. I was going to do the quad. I was going to do it differently. So the first time I specified the networks, and this time I'm just going to use an overall network statement. So this time we're just going to use our quad 0 statement, network 0.0.0. Whoa. And we'll do a 255.255.255.0, or 255, sorry. That'll just specify that all the interfaces on this router are going to participate in EIGRP. And you can see now that we have a new neighbor adjacency with router 1 that just came up, so that's good. Now we've got to do IPv6, and remember, by default with IPv6, all the interfaces are already participating. Spell right. So we'll do address dash family IPv6 and our autonomous system 1, and I did it again. It's not that I don't know the command, it's that I always forget to put that in first. IPv6. I'm going to try not to forget it the next time so you guys can see it all flow at once. There we go. Now let's go back into our process. Ooh, I just created a new process by accident. Forgot to put the E at the end. So we got to exit out of here. And first I'm going to get rid of that process that I created. And then we'll go back into our process we actually want to use. Router EIGRP example, actually spelled out fully. Address family IPv6, autonomous system 1, and done. And then you could also see right away too that we have a new adjacency. Notice though this time, which is interesting, let's see if we can scroll up. The first time we formed our neighbor adjacency with the IPv4 address on R1, but this is not our IPv6 address on R1. Remember, our IPv6 address starts out with 2001 DB8. This is the link local address. IPv6 forms neighbor adjacencies using its link local address. And since I didn't specify one, it dynamically came up with one. And you can tell that it's the link local, even if you didn't know that that was the default behavior, that EIGRP used the link local addresses to form neighbor adjacencies. The FE80 here indicates it's a link local address. So we're done there with our basics. We'll just exit once and then we'll go over to router 3. Okay, so now in router 3, we're just going to go through our 3 basic commands again and then verify our routing is working. And after that, we'll do a router ID and a passive interface, and then we're done. You know what I'm going to do before I even go into the address family configuration here, or the, named EIGRP configuration? I'm going to do IPv6 unicast routing so you guys can see me. Remember to do it this time before I start all the other stuff. So now let's do router, spell router correctly, EIGRP example, address family, IPv4, autonomous system of 1, and then our networks. And we can we're going to have them all participate again, so we can specify them, or we can go ahead and we can type them in specifically. We're just going to use our quad 0 again because we saw it the first time. So we know how to put in a network address and a specific wildcard. I think we can handle that. So this time, because we know we're going to have all our interfaces participate in EIGRP, we're going to use our quad 0 network. Wow, have it. There we go. And we saw our adjacency came up with router 2. Router 2's address is 2.1. I should say it's router ID is 2.1 as well in that case, because that's going to be the highest address. Yeah, I didn't see what it was going to be. Whoops, sorry, got distracted a second. All right, so let's go ahead and configure our IPv6. I'm going to exit back one, and we'll do our address family tab. Complete address family, IPv6, autonomous system 1. Done. We should see our neighbor relationship come up. And we do, and again, in our link local address as well. So we notice that that's just a little bit different than what we would have seen with our IPv4. Okay, so all our basics are actually done. Should we see that we can get everywhere? So let's do a ping sourced from our loopback address all the way to this interface here, our 3.1, which I realize it doesn't have a 1 there, but that's what it is. It is a 3.1. So if we end and we ping, let's hit a Control C here, ping 192.168.3.1, and our source is going to be 192. Move my cursor, 192.168.4.1. So we pinged from all the way from the inside of router 3 to the inside of router 1. So our routing is working great. So let's go ahead. What else did I say I wanted to do? We want to, well, let's do some verification. So let's go ahead. I'll go back to router 1. So as I go back to router 1, let's do some of our show commands. So if we do a show, let's do enable. I have no passwords because we're just demonstrating, right? Let's do a show IP Eigrp neighbors to see all our neighbors. So our IPv4 neighbor on R1 is 1.2, which is our router 2, and that's correct. If we do a show, hit the up arrow. And we replace IPv4 with IPv6. We see our IPv6 neighbor, and you see that it used its link local address. What else do we want to see? So when we do the we do the show IP or IPv6 Eigrp neighbors, we're going to see which the router that we're on. We're going to see which routers it's formed neighbor adjacencies with. If we do a show IP Eigrp topology, in here we're going to see when we do a show IP Eigrp topologies, we're going to see our successors and our feasible successors in here. Now we don't have any because we have no backup routes in here. So all of these routes would actually be in the routing table as well, because we take our routes at the topology table, and we take our best routes and we put them in the routing table. So if we do a show IP route, we also have our routes. And our D, if we go up here to our codes and we do a show IP route, in fact, I can just pull this down so we can see a little more. The D signifies that it's Eigrp. So this route was learned through Eigrp. As well as this one down here. If this was an external, an Eigrp external route, for example, through redistribution, there would be an EX next to this D. There'd be an EX over here. First number here is your administrative distance, and then our metric. And one last command, let's do a show IP protocols. We're actually going to use that one again a little later. But this command is useful for a lot of things in your network, especially if you're running multiple protocols. In this case, we're running Eigrp in Autonomous System 1. We have no passive interfaces, otherwise it would say in here, and we just know that we do at this point. One way to tell that you're using a wide metric, other than knowing that by default, that's what it's going to use with named EIGRP. This K6 value here, when you do a show IP protocols, indicates that we're using wide metrics. Otherwise, we would stop at K1 through 5 for our metric weights. So let's go through. You can see our router ID. And just as I said, on this router, the highest up address, there are no loopback addresses. The highest up physical interface address is the 192.168.3.1, because remember the other one is, let me move this, the other one is 192.168.1.1. So our router ID ends up being our highest up physical interface in this case, because we have no loopbacks. And let's go ahead and go over to R3 and check out that loopback thing, because remember, remember that it'll use the loopback address first if a loopback is active. All right, so we'll click over to R3 and let's do a show IP protocols again. And in this case, the router ID is 192.168.4.1, which is the loopback IP address. Let's go ahead and set our router IDs next. We're going to set our router IDs in all the routers, and then we're going to check, or we're going to make this interface passive. All right, so now I've brought back the router 1 terminal, or the R1 terminal, and the last of the configurations that we want to do is explicitly configure a router ID and configure passive interface. So specifically, we're going to make, let me move this over, I guess she left it over. We're going to make this interface here passive. Oops. This one right here, we'll make that one passive. Basically, a passive interface doesn't send out or process EIGRP hellos. And given that this here is now the access layer, and we're not routing here, there's no need to send out or process. There's no need to send out the EIGRP hellos. And if for some reason someone would hook up a router here, which is probably something we wouldn't want to have happen, we also would not want this interface to process those packets as well. So let's go ahead and configure that. First, we'll do our router ID. Whoops, gotta go enable mode, big T. Router EIGRP example. We'll do address family, IPv4, whoops, wow. Autonomous system number 1. And then we just have to do EIGRP, router ID, and then give it a router ID. We'll use 1.1.1.1 for router 1 and 2.2.2.2 for router 2 and so on. So that's our new router ID. And we can see for a moment it went down due to a route configuration change, and then it came back up. All right, now let's do, let's get out of there. We'll do a show IP, show IP protocols. Wow, spell Renee. There we go. And in there now, we should see our new router ID, and we do. Okay. Now let's go ahead and configure our passive interface. I'm going to actually pause a second and reset this terminal. You can see it's sticking down. I just reset it to bring it back up here. I'm supposed to get it done without pausing, but all right. So anyway, router EIGRP example. And address family. Oh, I want to move my cursor again. IPv4. IPv4 what? Autonomous System 1. AF interface. Now I can do it two ways. I can specify the interface. So I can go interface. I'll do that first. Let's do interface G 0/1 we said we needed to do. And we'll make it passive. So we go into the interface configuration for our one interface, and we make it passive and hit enter. And we'll go back. Let's do a show. Now let's do a show IP protocol. Now let's do a show IP protocols. There's our passive interface. Took me a second. And now we see our passive interface of gigabit 0/1. Show IP EIGRP interfaces. And now you'll notice that the G001 doesn't actually show up here. So that's, even though it is participating in EIGRP, it doesn't show up in the show IP EIGRP interfaces, but it should still show up if I do a show IP EIGRP topology. You know, we still have that, we still have it in there. Because then this network is going to be propagated through. It's just that we're not sending or processing EIGRP hellos on the 01 interface anymore. Okay, so we did the router ID. Let's do a, just stretch this down because it keeps going in half, but let's go ahead and do a show IP. Actually, I'm going to do it one other way first. So let's get rid of this passive interface configuration, and let's do it the other way. So this way, I specified only the interface that I wanted to be passive, and I specified that interface to be passive. The other way we can do it is by default create all interfaces are passive, and then say that the interfaces that we don't want to be passive won't be passive. So if I get rid of my configuration that I just did, do a lot of tab completion, don't we? IPv4, address, family autonomous system 1, if interface G0/1, no. Just want to get rid of that. If I do a show IP EIGRP interfaces, if we do a show IP EIGRP interfaces, I realized I forgot to show you beforehand too. Now that I've gotten rid of G01 as being passive, we see it in our show IP EIGRP interfaces again. Now let's go back and let's do it the other way. So remember, one way of making interface passive is to specify the interface that you want to be passive as passive. The other way is to default all interfaces to passive and then make the interfaces that you don't want to be passive not participate, not passive in that case. So let's go ahead and do config T, router EIGRP. IPv4. AF-interface default. So now we're basically default interface configurations. So apply to all the interfaces. And then we say passive interface and hit enter. So now we've got to go back through though, because we don't want, you can already see we're going to lose our neighbor adjacencies, which we did right away. We made the interface passive, which means it's not sending hellos, which means we're going to lose our neighbor adjacency with, let me move this over. We're going to lose our neighbor adjacency between R1 and R2, which we did right away. If that's okay, we're going to fix that. As part of our configuration, we're going to bring this one back over. And hit enter. And we're going to go into AF interface G0/0. That's the one we don't want to be passive. No passive interface. And then as soon as we do that, we can see we formed our neighbor adjacency again with R2 because we made this one not passive. And now we form our neighbor adjacency again. Now we've done IPv4 and IPv6 on here. So let's verify some things with that. Well, let's first do a show IP protocols. This is a great command as far as there's so many things that you can see in here, especially if you're troubleshooting. But then again, our passive interface is now G01. We said all of them were going to be passive, and then we made 00 not passive, which means all the ones that are left are going to be passive. In our case, it's only 01. And again, if I do a show IP EIGRP interfaces, 01 is gone. Okay, now let's do a show IPv6 EIGRP interfaces. We see both of them. Show IPv6 protocols. And you can see we have no passive interfaces. We only configured, it applies only to that address family. So we've only configured G01 to be passive for IPv4. I won't repeat this through all the routers. I'm just going to do it on this one. I guess I was going to do that anyway. I suppose it doesn't matter. Config T router EIGRP example. Now we got to go into the IPv6 address family, IPv6. And we're going to make the interface passive. So we just specify the interface since we defaulted for 4. We'll do it the other way for this one. So then we do AF interface G0/1 and we make it passive. And we type end, and then we do a show IPv6 protocols. And now we see that gig 01 is passive now. Something else I wanted to show you. Notice our router ID for IPv6. So this time we looked at IPv6 protocols. Before, when we looked at we just looked at IP protocols, which infers IPv4. I said the router ID, we had changed the router ID to 1.1.1 and that showed up. But again, both of those configurations need to be done within the address family that you want to adjust. It's okay that IPv6 is using this router ID and IPv4 is using 1.1.1.1. It will work. If you wanted to change it, though, you would have to go into the address family for IPv6 and enter the router ID command. So we do config T. Do show IPv6 protocols. And again, I haven't done this with you guys yet. I'm sure you've seen it before, though, if you're watching this video. I don't necessarily have to exit back all the time. You can use the do form of the command. So I just did a do show IPv6 protocols from our address family configuration and got the same results. Also notice while I'm talking, we're doing this, that we lost our neighbor relationship and then it came back up. And that was just due to changing our router ID to 1.1.1.1 for IPv6. Okay. And I could go through and do that with the rest of the routers. I'm not going to do that. I suppose I could do it one more time without all the explanation. You'd see it nice and clean. So I'll go ahead and I'll change the router ID on, no, how about if we go over to R3 and I'll make the loopback passive as well. We'll do that. First we'll do a show IP route to see that we do see the network for the passive interface. So I'll go into R3. All right, so we have R3 back over here. In R3, we're going to change the router ID in R3 real quick, and we're going to make the loopback passive after we do a show IP route to see that, in fact, we do have, I just took it and then I moved it again. Let me erase some stuff here. All right, so just erase some stuff. So what we're going to do is do a show IP route over here to see that we do see this network in the routing table for R3. So we are propagating the network, which is what we want to do. We want R3 to be able to get to our internal network here, our access network area. What we don't need is we don't need this interface to be sending or receiving EIGRP hellos, because there's nothing to form a neighbor relationship with on the other side, nor do we want there to be. We don't want someone to just walk up and plug in a router or something and have issues there. So we made this interface passive, but we just want to see that, yes, the purpose of that is we're not processing those hellos here, but our upstream routing is learning about this network. And it will learn the same thing with IPv6. It's learning about the network, but it's not having to process those packets. So first thing, show IP route. And we verified, yes, there it is. So what I just said to you is true. I mean, I can tell you things in theory all the time, but sometimes it's nice just to see that it's true. If we do a show IPv6 route, we should also still see the IPv6 route, and we do. So let's go ahead and change our router ID, and we're going to make the loopback interface that I configured. Remember, the only reason I configured the loopback interface is so we had another network. We're going to configure that as passive, and then I think then we're done. We've done it a couple times. That seems pretty reasonable. Config T router EIGRP example. Address family, IPv4 autonomous system number is 1. EIGRP router ID. Here is going to be 3.3.3.3. Remember, each router has to have a unique ID. So I can't use 1.1.1.1 again on this router. hit enter. And so we did the router ID. Now we want to do the interface. So we do AF interface. And the interface is the loopback 0 interface. Oh, now that the interface I went to had nothing to do with this. Remember, this is what happens when we change, when our process is running and we change the router ID. So we went up, we went down, and we went up. So now we're into the loopback interface configuration. And we're just going to make it passive. And that's it. That's for IPv4. Should we do it for IPv6? Sure, we'll just do it for IPv6. Family, IPv6, Autonomous System 1, EIGRP router ID 3.3.3.3, right? AF-interface. Oh, not jig, sorry. The loopback 0, passive, done, sorry. Again, this had to do with our router ID change here. I should have waited. I did the passive interface thing right away. Now, show IP EIGRP topology. We still see our loopback in there. Show IP EIGRP interfaces. And we don't see our loopback in here anymore because it's passive. That's how it behaves. We can do a show IP protocols. And the things we're looking for right now are that the loopback 0 interface is passive. And our router ID is 3.3.3. If I do a show IPv6 protocols, I look at the the address family or the IPv6 EIGRP process, and I see that my loopback 0 is passive, and my router ID that I typed in and changed is changed. So I think that's it for this one. We went through some just basic named EIGRP configuration, a couple verification commands, and then configured router ID explicitly and configured interfaces to be passive and see how they look different in our output. And that's it.